Hello everyone, my name is Venkatesh Polla. I am from Group 9. So I did a project called Image Captioning Generator. Let us go to the introduction part. So what is image captioning? Combining computer vision and natural language processing to generate a textual description for images is known as image captioning. It's like we already know, like we generate images using the text. So develop a model. Purpose of the project is develop a model to generate accurate and contextual relevant captions. So when we give exact captions, what we want to get an image, so that it provides the exactly the same thing. Applications like aid for visually impaired content indexing, multimedia retrieval things. Let us go to the technical foundation. So I use like so here is a picture. Here is a picture how it works for the how it works, like taking the picture and using the ImageNet dataset. Like it will take the picture, external visual features of them from the images, and use long short term memory networks like LSTMs. You can see here how it was used and how it works, and it extracts the images and make the captioning according to it. Integration strategy combining LinuxNet 201 and LSTM for optimal features and sequence processing. These are the things which I used to create this model. And I'm sorry. So these are the related work and inspirations, like Vinals, which is introduced to show and tell model of a foundational architecture for image captioning, and XUKAL 2015. This is also developed a show attend and tell integration attention mechanism to improve focus or relevant image parts. Influence on current project. These studies and underscore the effectiveness of the merge CNS with the LSTMs and the benefits of the attention mechanism. So the dataset and the processing. Let us go to here. I use like Flake 8K featuring 8,000 images with the 5 different captionings, and this dataset I got it like a very hard thing to get the dataset. Image pre-processing, like resizing and normalizing images to uniform dimensions for consistent model input, and like caption pre-processing, so tokening the text into squeezes, facilitating the LSTM processing. This is the architecture of the model. So here you can see in the graph like a user how it goes, like one step by step, like a user upload a flick 8K dataset, like which I use the datasets which have 8,000 pictures, and the image gets input, and it detects objects in the images using the CNN model which I already told you in the technical time, and make captions, consider objects using the LSTM model, and train the model using training to make better captions, display the caption. So here I already said like I use for the extraction I use DenseNet 201 chosen for its efficiency in featuring propagation and detection of redundancy. Sequence generation. LSTM network handles the sequential data, ensuring grammatical coherences, and integration details. It outputs connected directly to LSTM inputs for real-time processing. So let us know how to the training the model, like frameworks which I used was TensorFlow and Keras for robust deep learning operations. Training approach is like batch processing and model checkpoints to manage the extensive training data effectively. Adjustments in learning rates, regularization to enhance model performances. So I use these things to train the model effectively. So a popular optimization algorithm used to adjust weights in the network to minimize the loss function. There are callbacks used to monitor, improve training. So there are model checkpoints, saves the model at intervals. Early stopping stops the training when the model performs, so stop improving on a validation datasets. These are the things which are used for the training the datasets. So here is the results after having a clear vision. After doing all the things I got this. This is how the picture is going to come. So model produces contextually relevant captions with high precision. For example, like we can see a kid was like a young girl in blue shirt is playing in water. So things like this, like yeah. And user feedback. So for positive responses of the human like quality and intuitiveness of the generated captions, we got this. For example, like we can see like here two dogs are playing in the grass, like something different like this. So showcasing before and after examples for image captions generates the model. Challenges and lessons learned. Combining feature extraction with the sequential data, and while doing this I got some challenges which are like getting technical errors, and it took me a lot of time to cover the, excuse me. So the importance of architecture decisions in achieving high performance. So when I'm doing this model optimization, I got little challenges, and I learned like giving it a right caption. According to the right caption, it was generating the picture. So this is how I took it. And future potential to enhance model focus and accuracy, significance of attention in the mechanisms. So and there are some future directions. Multimodal approaches, like exploring additional model architectures to handle diverse data types. Expanding datasets is increasing the variety and size of training datasets to improve model robustness. Like I use different type, but I think it can be more. It can be like can do in variety types, and having a different sizes of datasets, we can do it in a different manner. And implementing dynamic focus, advanced attention mechanisms, implementing dynamic focus capabilities to refine caption accuracy. So by implementing the dynamic focus capabilities, like if we gave it an image, like we can improve those things, like we can give it more clearly, we can generate more better captions than that, how it is going. So that is it. So let's come to the conclusion. Like summary of findings: effective integration of CNNs and LSTMs facilitates accurate image caption generation. Like impact on field: potential advancements in aiding visually impaired individuals and enhancing digital content accessibility. And let me go through my code once so that you can understand it easily. So here is my code. Yep. First, I imported different types of data sets, like I imported different types of things in it, like data sets. And this is the data set which I gave it in a path. And I tried to give some pictures, like I want to view how it was coming. So I gave it a I give it a little try, and how it was image getting. So I give it like that. And like loading, like these are used to load image files into Python, convert them into a format suitable for neural network processing respectively. So yeah, this is crucial for text processing in neural networks. It converts text into sequences of integers where each integer represents a specific word. This is necessary because neural networks do not process raw text, they process numeric data. And there is a sequence, like this function is like a pad sequences. This function which is used to ensure that all sequences of data, in this case like text or anything, have the same length. This is uniformly required because most neural networks architectures expect input dimensions to be constant. So I tried to try how it was getting in, and I tried to get some example. So This is how I got the examples. Like for example, we can see like here are some example which is capturing so good. So the black and white cat animal is in the grass. So this is how it is, and this is an example model which it was like the normal one I tried to get. And to integrate this, and I use it like laser types ls long short term memory, embedding these all training models. And I also used pre-trained models like VGG16 and DenseNet 201, all these things. So model training, I did some model training here as well, like popular optimization algorithm used to adjust weights in the network to minimize the loss function. And there are model checkpoints, early stopping, and like because there is, as there are 8,000 pictures, it would take me days to complete every picture of it. So I took like early stopping. I used this function called early stopping so that it takes less time for me. So these callbacks used to monitor, improve the training model. So model checkpoint saves the model at intervals. Early stopping stops training when the model performance stops improving on a validation data set. So and reduce plateau reduces the learning rate when a metric has stopped improving, which can help in fine tuning the model. So based on the things which I've said before, this is how I did this. And the data visualization. So here is an example like how I plotted this model. So here is how we give the input layers. Like we can give by two types. Like there are two types of images like having the same wavelengths and all. So it takes the dense in two types and it reshapes it. And there is another other type also which is embedding this, and they concentrate it, and then it goes to the LSTM, then it dropouts, then it adds the thing. There are other way also which directly comes from dense to the add, and then goes to the dense one again. So this is how dense 201 works out, and it dropouts that, and dense, here comes the output. So I did a little summary on this. So dropping out data metabolism and seaborne things. So this is how I run the code. These are the functions which I used in this. And after trying that, I used to plot a graph as well. So this is the model loss graph. So how much it losses the when we give the picture. So this is how the graph is. So we took x-axis as epoch and y-axis as loss. So this is how it takes from that. So this blue line indicates the training thing, and the orange one indicates the visualization and validation of the image. By doing all the backside of this coding, I got these images. After doing all the things, I think this model can be generated a way better more, but I tried according to my best. So yeah, thank you so much.